We're looking at 8-1 notes on variation functions. It's pretty basic, and I think you're going to be fine with this, but you do need to know the names. So a direct variation is simply y equals kx. A direct variation should remind you of y equals mx plus b. What's y equal mx plus b? That's your slope-intercept. So you have a slope, rise over run, which is a constant rate of change, and you have a b, which is a y-intercept. What's missing here is b. So the direct variation equation is always y equals kx plus 0. So if we were graphing this, we always stay and start at 0. So that is the idea that this line, if we do this, it will be a line that's linear because it's x to the first, will always run through the origin. It could be a negative slope, a steep slope, a little flattened out slope, but it will always go through the origin. And that's what makes this different than y equals mx plus b. And we call k the constant of variation. So the constant of variation is k. So instead of calling it m for slope, it's the constant of variation. I don't need two ordered pairs to find the constant of variation like I do the slope. The constant of variation is basically k equals y divided by x. So how did I get that? Well, if you have y equals kx, and I tell you to solve for k, the constant of variation, you would come in and divide both sides by x, and that's what we get. K, the constant, is equal to y over x. Now that should remind you of slope. Isn't slope the change in y over the change in x? Slope is that y2 minus y1 over x2 minus x1. We don't need that. We just need one ordered pair because we know it's a constant. So an example is y equals 4x. That means k, the constant of variation, is 4 or 4 over 1. So you're going to start at 0. And you're going to rise 4 and run 1. So it's very much like graphing a line using slope. Okay, I will come down to the examples in a minute. Now, we have this inverse variation. Well, the inverse variation, instead of multiplying by x, we are going to take k and we're going to divide. The inverse of multiplication is division, and the order does matter. So the inverse variation is y equals k over x. If I ask you for the constant of variation, k is equal to x times y. So how do I get that without memorizing all of this? I do need to memorize the basic equations. How do I get the constant of variation? I would take that basic equation, and I need to get k by itself. So how do I get rid of x? I would multiply out by x, and you see that my k is equal to xy. So I need to memorize these, and I should be able to get to solve for k. All right, now when you graph this is going to look different. We haven't really graphed things with a variable on the denominator. So this is x to the first. It's going to make something with something called asymptotes, which we're going to get to later. As I graph, this side is going to keep going up, and it's going to get really close to the y-intercept, but it's never going to cross it. That's called an asymptote. This graph is going to come down, so as it's approaching 0, it's going to go to negative infinity. So as x approaches 0, this goes to negative infinity. As x approaches 0 from the right, like heading left, it's also going to positive infinity. Now, as x approaches positive infinity, as y approaches positive infinity, as y approaches 0, as it gets closer to 0, x is positive infinity. So as x goes to negative infinity, the y keeps going to 0. So this is going to keep going, and then you would show this with like a dashed line. Again, it's called an asymptote, where it approaches but it never crosses, and you have another asymptote here. And we'll learn more about asymptotes in this chapter. Okay, sorry I kept getting myself backwards. All right, last one is called a joint variation, and it's y equals kxz. And I put a little line through my z to make it not look like a 2. Okay, this one, notice there's no graph. This one is, you have a third dimension. So if you were graphing this, you'd have your normal xy, and you'd have z coming out at you, like that third dimension. What does k equal here? Well, k equals y divided by xz. So how do I find that? Y equals kxz. And if I want to solve for k, I would simply divide both sides by this chunk to cancel it out. And that's what I get. Okay, so you're going to need to know the name and the basic equation for each one. and then you should be able to find k. So if the directions say what is the constant of variation, you need to know you're looking for k. So there is some new vocab here, okay? The hard thing about 8.1 is we're going to learn this, and then we're moving on to different content. So this would definitely be note cards, direct variation on the front, y equals kx on the back, maybe a little note about k. Same thing here and here, but you've got to know the constant of variation is k. You have 3 different equations. Graphs look like this. Okay, so let's go down to the bottom for examples. If y varies directly, that's the wording. Y varies directly. That's how we know it's a direct variation. Okay, that's how I know which of the 3 it is. And it says y varies directly with x. So y is your dependent variable. It's dependent on x. Y is 10, x is 14. Find the constant of variation and determine the equation to represent the relationship. Notice we want the constant and the equation. Okay, so y equals 10, x equals 14. And what's the direct variation equation? Y equals kx. So there's my direct variation. As soon as I see that, I know y equals kx, and just plug it in, guys. 10 is equal to k times 14. Now, I need to find k. It said find the constant. So what would I do here? Divide by 14 and reduce your fraction. So what do we get for k? Not 2. It should be 5/7, right? All right. So 5/7. That is your constant of variation. And then what is your equation? Go back to generic. Y equals 5/7 x. So constant of variation, direct variation equation. Okay, look at the wording in the next one. It says y varies what? Inversely. So this is your inverse variation. Inverse variation. And that inverse variation equation is y equals k over x. We invert that multiplication to division. All right, they gave us that y is 4 and x is 12, so all I have to do is plug it in. I almost wrote y. So y is 4, and that equals k over 12. Now, I need to get k by itself, right? Like, I got to find k to write the equation. So what should I do? How do I get rid of that divided by 12? Don't I just multiply by 12? So this is easier than a lot of the stuff we did. We just need to know the words. 12 times 4 is? I was going to go with 48. Yeah? Now, that's the constant. That's the constant of variation. What's my equation? Go back to generic. Y equals 48 over x. So this was just like writing equations back in chapter, I think, 2, where you found the slope, the y-intercept, and then you plugged it in. So we use what we're given, this ratio. We find k, and then we write it, so then we can put anything we want in for x. Okay. Keywords, varies what? Jointly. So what is that equation? So this is going to be a joint variation. This is what they look like. And the equation is y equals kxz. Now the order doesn't matter. It's just we normally write it with the k first and then xz. What do we know? Well, they told us y first, which is 42. They told us x is 9. And z is 7. You don't have to rewrite it, but I want to make sure we knew where those numbers were coming from. So 42 equals k, we don't know that, times 9 times 7. Now, I prefer to use parentheses, especially if there's a negative number. I don't want to think it's subtraction. So I get 42 equals k times what? Yep. Then I'm going to solve by dividing both sides by 63. All right, what do we end up with? Reduce your fraction. What is it? Oh, I was thinking, yep, I didn't divide far enough. I needed to go again. All right, 2/3. That's your constant of variation. What's your equation? Y equals 2/3 xz. That's it. That's how simple it should be. Now, it is easy to make mistakes, and you need to know the equations. Got it? Good? Can I flip? Oh, hold on. Come back. There's two other words you could see here. I forgot. I wanted to add this on. You might also see directly proportional instead of varies directly. So you know how up here, it's up at the top, it said varies directly? You might also see the term directly proportional. Okay, varies directly, directly proportional. It's that direct idea. Do you get that? These are proportions or ratios. So varies directly or directly proportional, varies inversely, varies jointly. Now, not everything is going to be, I say that. I say not everything's going to be kx and y. We have that here until we get down to this one. So you do have to pay attention that they could be using different variables. So you have to watch what's defined. Now, it says determine whether the equation represents a direct, joint, or inverse variation, and then identify the constant of variation. Okay, so what am I looking for? Well, this has y equals 2x. This is like k times x. So this would be a direct variation. And I didn't have to do any math. What is k? K is 2. So if this helps, because you guys might have to flip back and forth, here are the originals. Now, this one says y equals 24 over x. Well, that matches with my inverse. So this is an inverse variation. And k is 24. So those are just like outright given. I didn't have to move anything around. All right, number 3, again, a little bit more obvious because you see it, kxz. So this is a joint variation. And k equals 5. Okay, now, number 4, it didn't lay it out for me. So I need to take a minute and I need to solve for y. All of these should be solved for y. When I go to solve this for y, I divide both sides by 3, and I get y equals x over 3. So I think some people want to jump to inverse variation because they see the fraction, but where's the x? And the top. If it's inverse variation, you're dividing by x. Okay. Isn't there a 1 that's in front of that? So dividing by 3 is the same as me saying y equals 1/3 times x. So this is a direct variation. And what is k? Positive 1/3. So be careful. It's not just because it's a fraction, it's where the x is. All right, look at number 5. Again, I want to solve every problem for y equals. So I'm going to divide by x, and I get y equals 36 over x. So I do have that fraction, and x is in the denominator, so this is an inverse. Yep. So you're going to show that work. Even if you think about it in your head, you're going to show me what it is. It's an inverse variation. And what is k? And what does k stand for? Like, what's the word? When I say what's k, I'm looking for the constant of variation. Okay, how are we dealing with number 6? I need to solve it for y. Okay, I have an issue with that. You are right. Mathematically, we have multiplication. So we should divide by 4/3. That's not going to work for me. 4/3 y equals x times z. So if you mathematically, I agree with you, it's multiplication, so we're going to divide. You can't leave me this, right? Like you can't leave xz over 4/3. 1, it doesn't look like any of these. And 2, it's not proper to have a fraction and a fraction. So what? Yeah, here's the deal. If you do this, you could take 1 divided by 4/3. Most people don't do that. So instead of dividing by a fraction, I would prefer to come in and multiply by the reciprocal of 4/3 to both sides. Now, the other option was to multiply out the 3 and then go back, multiply out. Did I just write it wrong? I should be multiplying by 3/4. Can you fix it? I wrote 4/3 again. My other option, we multiply both sides by 4 and then, or 3, and then come back and divide. Okay, now that I have it sorted out right in my brain, I'm going to put it out front. 3/4 times xz. All right, so this is a joint variation. And what is k, the constant of variation? Should be 3/4. Okay, now what about number 7? What do you want to do? What do you want to do in number 7? Yeah, if I need to get the x out of there, I'm going to multiply out the x to both sides. Now, I'm going to write this as y equals 2/5 times x, but you could also see it as 2x over 5. You just can't have the x in the denominator. So this would be what? This is a direct variation. And what is k? K is 2/5. All right, now the next one doesn't have x, y, and z, but it does have a and bh. So we're going to solve for a like this is our independent or dependent variable, and it seems like this is probably area of maybe a triangle. You know, what's the formula for area of a triangle? Half base times height. So we're going to treat a like it's our y, and we're going to divide both sides by 2. And if you write it as a equals bh over 2, that might throw you. Couldn't I write it as a equals 1/2 times b times h? And so the a is like my y, the b is like x, and the h is like z. So this would be a joint variation. And what is k? 1/2. Well, that was fun. Okay, now, I know some of you might be working ahead, but I need you to make sure you're getting these right. So it says if y is directly proportional, there's that term, directly proportional is the same as direct variation. See the keyword direct, to x. And y is 28 and x is 7, calculate x. Now there's 2 ways of doing this. I'm going to show you one method here and one method here. The first method is to take your y equals 28 and your x equals 7 and find k. So 28 equals k times 7. And then divide by 7, what's k equal? 4. So then I would write my equation, y equals 4x. And then I would do the second part of my problem, and it says when y is 52, find x, yeah? So 52 is equal to 4x, divide by 4, and what do you get? Well, in case you didn't know this, 52 divides evenly by 4, and it is 13. And that's all I asked for, so you could do it that way. The equation, the direct variation equation, was y equals 4x. The direct variation, or k, was 4. That's one way to do it. Now, the other way you could do is proportions. It says r is directly proportional to the square of s. Okay, you need to pay attention that it says to the square of s. Did anyone catch that? So if you're a little ahead of me, you better back it up.
I already know it's right.
Okay, you're amazing. So I was going to show you could do it with proportions, but I'm going to do this one the regular way. I lied about showing the second way. We'll stick to this. So r is like my y, and s is like my x, but notice it says the square. So it's going to be r equals k times s squared. That's what I'm using. So this is going to be 72 equals k times 12 squared. Well, that 72 equals k times 144. And now divide both sides by 72 or by 144. And the answer is not 2, folks. What's the answer?
1/2.
K is 1/2. Now, you're not done yet, because it wanted you to find r when s is 8. So I need to find r when s equals 8. So go back to your original. R equals 1/2 times 8 squared. Well, isn't that 1/2 times 64, which is
32.
R equals 32. Am I waiting? Did someone say wait? Let's read through this. The dollar amount D that Megan earns varies directly. There it is, guys. D is like your Y. It varies directly with the number of hours, which is like your X, that she works. In the last paycheck, she earned this much money working 18 hours. If her next paycheck is $90.75, how many hours did she work? Okay, so you could solve this differently. You could solve proportions, but I am looking for you to show me this. So D equals K times H. And so originally they gave us a D value of 148.50 for 18 hours. So we know this information. So we're going to take her total dollar amount, 148.50, equals K times 18. And then you're going to divide both sides by 18, and what do you get for K? Okay, I need you to stop, and I need you to tell me what that 825 actually means.
The hourly rate.
The hourly rate. Guys, if you think about it, you took dollars and divided by 18 hours. So it is $8.25 per hour. We should know that because we knew the labels, we knew what operation we did. Okay, so if I write my equation, her dollar amount is equal to the constant of variation, or her hourly rate, times her hours. So we know her next paycheck is $90.75. How many hours did she work? What do? Divide both sides by 825. And what does, oh, not X. What do we need? H. We use this as H. What does H equal? It equals 11. And then because it's a word problem, you're going to say 11 hours.
But it already knows that it's hours.
You're going to write it because that's how we roll.
11 hours.
Okay. Now, notice on here, I'm telling you these are joint variation. I'm telling you which ones they are. They will be mixed up. So what words do I look for joint variation? Varies what? Jointly. Okay, so let's knock this out, guys. I'm giving you this information. We want to use Y equals K times X times Z. They gave me Y. They gave me X. And they gave me Z. So I'm going to find 8 times 15, 80, okay, 120. I'm going to find K, which is?
Yeah, some number.
Thank you. Divide by 120. I believe it reduces to 2/5. Anyone double check my math?
Yeah, that looks about right. It looks good.
Looks good and being right are two different things.
It looks good enough.
Okay.
If I actually did it, it would be right.
My equation is Y equals 2/5 times X times Z.
That's right.
Okay, thank you. Now they gave me X and Z, so I'm going to find Y. So Y equals 2/5 times 14 times 20. I would just type that in the calculator all at once, and we should end up with the same number of 112. So you're showing me what you did, not just, oh, this is K. You're going to show me what you put in. You could skip a step, but show me something and show me what you did to solve it. Okay. P varies jointly with Q. So P is like your Y, and Q is like your X, and it's the cube of R. So R is like your Z. So pay attention to this one. When I go to write this equation, P equals K times Q times R to the third. And we don't want to miss that power. So do you see how I can tweak this? It's not just X, Y, Z. It would have been K, X, and Z to the third. And also I think it helps to label them. All right, so P is 270. We don't know K. Q is 6, and R is 3 to the third. So it's important which one you cube. Remember, you are going to cube it first, and 3 to the third is what? 3 to the third, 27. And then I'm going to multiply 6 times 27, and we should get 162. Divide, and what does k equal? And I want to keep a fraction. It should be 5/3. I don't want to round a decimal. So keep your fraction. And now we need to do the next part. We want to find p. We know q is 5/3, or k is 5/3, q is 3, and r is 5. And don't forget your little power of 3. Again, I would just type all that into the calculator, and we should get 625. If you really look at this, 5 to the third is 125. These 3's would cancel, and then times 5 again. Okay, go ahead, take a second and read number 14. It varies what? Jointly. So that would be y equals k times x times z, but you could choose to use other things for the variables. Let's see. Tom opened the account 3 years ago, so that would be your time. He started with $1,200 and he earned this in interest. How much interest will be earned 8 years after opening the account? Okay, now this could also be I times KPT. I standing for the interest, K is the constant rate of change, P would be the principal amount, and T would stand for time. Okay, so that's what these stand for. Principal amount and time, I is the interest earned. So he opened this account. He got $144. That's like your interest. That's the I. He opened the account. Principal amount is your starting amount at $1,200. And time is in years. So clean this up. You get 144 equals what? Yeah, and then we have to divide. Now, this is going to give me, I'm going to keep it as a fraction of 1/25. Remember, this is like the interest rate. I don't know what 125 is, or 1/25 is offhand. 125. 0.04. So it's like a 4% interest, and it's just like a flat interest rate. Okay, so when I go to do this, I would have my equation. The interest earned is going to be 1/25 of the principal amount times time. So we want to know how much interest they are going to earn if they invest. How much are we investing? How much interest will be earned after 8 years of opening the account? So we're going to have that same 1,200, and this is like a simple interest rate times 8. So I found that I is 384. So what's that mean? $384 in interest, and that will be over 8 years. So again, it's a very simple interest rate. It's not like a compound. Okay, last couple examples here. Again, these are specifically given to you as all of these are inverse, but they're going to be mixed up. So we're looking for that inversely proportional, which is y equals k divided by x. Okay, so y equals, I need to write y. Y is 7.5. And that equals k divided by 8. Now, how do you get rid of that divided by 8? Multiply by 8. So what do you get? K equals 60. Now that we know k equals 60, we are going to do y equals 60 over x. So we have 5 equals 60 over x. How are we going to solve that? How do you solve this? Yeah, as much as you want to get x, like it's in the denominator, so we're going to multiply both sides by x. This is like a two-step one. So I have 5x equals just 60, because that's going to cancel. Then divide by 5. So what does x equal? Should be 12, right? So that was a little different because we get the x out of the denominator. All right. M is inversely proportional to the square root of n. So m is like our y, inversely proportional, and this is like our x. So we would have m equals k times n with the square root symbol over it. Not squared, but square root. All right, so m is 27, k and n is 16. So they made that nice. This would be 27 equals k times 4. Divide both sides by, I feel like I just screwed something. Oh, guys, inversely proportional. Shouldn't this be divided by? Yeah, ignore mine. I just realized I screwed something up. And I can't find mine. Okay, ignore mine. Sorry. This should be m equals k over the square root of n. That's what I should have. Okay, and then we're going to go with 27. I'm really not doing well. K over the square root of 16. All right, there I go. 27 equals k over 4. To multiply the 4, k is what? 108? Do we agree with 108? Okay. It was really easy for me to screw that up because I was thinking about the square root, not the inversely proportional. Okay, well, now that I know k is 108, it is going to be m equals 108 divided by the square root of n. So it is going to be m equals 108 divided by the square root of 64. So 108 divided by 8, and what do we get? 13.5, or reduced fraction of what? 25, or no, 27? Last one. Adam's driving to Disney World, and it varies inversely with his average rate of speed. Okay, so you could use whatever variables you want. If we're talking about time and then k over rate, you could do it that way because the time to drive is like the y. That's why I use t for y. And his average rate of speed, so I use r like my x. All right, it takes Adam 10.8 hours. So 10.8 is the original t equals k and an average of 50 miles per hour. So we would multiply both sides by 50 and I should get 540. See if you agree with me. Then the time is 540. That's the constant rate of change divided by his rate. So how long would it take him to drive, or take him at an average of 60 miles per hour? So we would take 540. That's the total miles he's driving, guys, and divide it by 60 miles per hour. And the miles cancel out, and the time should be 9. So 9 hours.